podcast where truth moves faster than a Holstein calf. No waiting on some pretty page. We're charting new ground in the digital age. From genomic codes to row-out facts, we cut through the noise, no holding back. Not your daddy's dairy news tonight. We're sparking debates with every insight. The ring's not where the real fight's at. It's in the data, in the channel chat. From pasture to processor to your morning cup, we're raising the stakes. Try and get ahead of herd. Yeah! Where the future's more than just a word. Ahead of herd. Come on! The bullvine's calling, let your voice be heard.
Welcome back to the Bullvine Podcast, where we cut through dairy industry noise to get you the insights that actually matter for your operation.
And today we're diving deep into a feature piece that's been generating some serious buzz across the industry publications. And this one's got layers and some genuine surprises that are going to force producers to fundamentally rethink how they've been approaching profitability, especially right now when milk prices are tightening up.
Absolutely. This deep dive is all about the unseen drivers of productivity. The concrete, the air, and the shade. The real structural foundation of milk yield.
It's a complete myth-busting piece.
It is. It challenges that fundamental assumption so many producers and consultants make, that your next pound of milk is automatically found in the feed bunk. It suggests that putting focused attention on the roof, the floor, and the airflow might be the single most profitable move you make this year.
It's the ultimate contrarian viewpoint, isn't it? Because, let's be honest, nearly every producer, every consultant, every nutritionist is fixated almost religiously on feed costs and ration formulation.
Of course. It's the biggest line item.
It's the biggest budget line item, and critically, it's tangible. You can adjust the protein level today and look at the milk weights tomorrow morning. But the core argument we're analyzing today is deeply provocative. That high feed costs are often profoundly wasted on what the authors provocatively term a broken barn.
You cannot fix nutrition in a broken barn. That phrase is really sticking with me because it implies a scenario where we are spending premium dollars, investing in the best genetics, utilizing the most cutting-edge supplements.
All the expensive stuff.
Only to have the physical structure of the facility capping the cow's biological potential, essentially stealing back those dollars through discomfort and inefficiency.
Exactly. And the stakes here are massive, not incremental marginal gains. The collective research posits that the difference between a truly comfortable cow and a restricted cow is anywhere from 1.7 to 3.5 pounds of milk
per cow per day.
And that's derived simply from the physiological benefit of getting just 1 extra hour of high-quality rest.
Just 1 hour.
That is high-margin milk you are leaving on the table every single day before you even open the next bag of feed additive.
Wait, and this is the part that demands attention. Did you catch that section about the investment required to unlock this? We are going to discuss why a minimal $50 investment in simple structural correction can deliver a faster and more reliable return on investment than almost any new trendy feed additive on the market today.
$50? It sounds almost unbelievable.
That is a statement that should make every farmer listening right now pick up a tape measure and an adjustable wrench before they even start their day.
And we are going to dive deep into challenging a deeply held, costly assumption, especially for those operating here in the northern climates, that heat stress is purely a southern problem.
A huge one.
We have detailed data showing that dairy farmers in places like Wisconsin, Michigan, and Ontario are hemorrhaging money due to performance drops related to heat stress without even realizing they've hit the danger zone threshold. The symptoms are subtle, but the costs are devastatingly real, affecting not just the current lactation, but the entire next generation.
The bottom line, which serves as the foundational theme of this entire analysis, is that comfort, the structure, the environment, the simple geometry, is still the cheapest, most reliable, and highest returning form of nutrition you can provide.
So let's get into it.
Now let's unpack this and get into the specifics of how the infrastructure operates as your silent partner in profitability.
All right.
Let's start with the immediate hard numbers on cow comfort. This isn't theoretical. This is research from institutions we all trust. The University of Wisconsin's Dairyland Initiative and the William H. Minor Agricultural Research Institute.
Right, the big names.
They confirm this direct, measurable, and highly predictable link between high-quality rest and milk yield. Specifically, every additional hour, A cow spends genuinely lying down yields between 1.7 and 3.5 pounds more milk each day.
Hold on, that fundamentally changes the optimization goal. That means my daily milking average is capped, not primarily by my genetics, and certainly not by the specific ratios of protein or non-fiber carbohydrates I'm feeding, but simply by how long my stalls physically and comfortably allow the cows to rest. If I'm buying $50,000 genetics and feeding a $12 ration, but the environment limits rest to 10 hours instead of 13, I'm wasting the high-end input.
That's the exact insight the research highlights. Think about the physiological mechanism when a cow rests comfortably.
Sure.
When she is lying down, fully relaxed, three things happen. First, and most critically, her blood flow to the mammary gland increases dramatically.
By how much?
By up to 30%.
Yeah.
That massive increase in perfusion is where milk synthesis happens, drawing precursors from the blood.
Oh, okay, that's huge.
Second, she is no longer burning maintenance energy standing up, shifting weight, or supporting her 1,600-pound frame. That conserved energy is immediately redirected toward the milk tank.
Right into the bottom line?
And third, and equally important, rumination is maximized when she is lying down, which drives greater feed efficiency.
So if I run a 100-cow herd and I can move their average rest time from, say, 10 hours a day to 12.5 hours a day, that's an increase of 2.5 hours. That is potentially 7 extra pounds of milk per cow.
The math gets big fast.
It does. That's 700 pounds of milk a day multiplied by 365 days a year. You quickly realize the enormous scale of the financial hole you're digging if your barn structure is essentially forcing them to stand or half rest in discomfort. That's hundreds of thousands of dollars in annual lost revenue year after year.
And often, the number one culprit is the historical structural mismatch between the barn design and the modern animal. You have to look at the historical growth rate of the Holstein.
They're not the same cows they were 20 years ago.
Not even close. Stalls built before, say, 2010 were designed for those legacy, slightly smaller Holsteins, averaging 1,100 to 1,300 pounds.
And our modern cows, the ones we are breeding for higher efficiency, higher yield, and overall larger frame size, are now commonly averaging closer to 1,500 to 1,600 pounds. And they're broader, especially across the hips. That is a massive anatomical difference.
Exactly. That difference of 200 or 300 pounds, combined with greater hip width, restricts their most crucial natural movement, the lunge space required for rising.
The lunge space, that's key.
It's everything. When a cow gets up, she doesn't just stand. She lunges forward to shift her center of gravity and gather momentum. If she is confined, if the neck rail is too low or too far back, she hits it.
And she'll stop trying.
She will. When she can't lunge, she stands in the alley, or she half rests uncomfortably in the stall, which is almost as bad as standing. That restricted movement is where you start accruing chronic injuries, lameness, and reduced rumination cycles.
What's fascinating here is the sheer simplicity of the fix relative to the size of the problem. We're not talking about a huge remodel.
No, it rarely requires specialized contractors or heavy equipment. It often boils down to adjusting the neck rail height and position. The modern, research-backed recommendation designed to accommodate these larger high-performance animals is setting those neck rails to be 48 to 52 inches high and positioned 68 to 70 inches from the curb.
So from the back edge of the stall where the cow stands.
Correct. That's the sweet spot for the modern Holstein.
So if you're running a freestall operation built in the 90s or early 2000s, that old, tight geometry is a guaranteed bottleneck on your performance.
Absolutely guaranteed. And the implications for different operations are critical. It's not just about comfort. It's about movement friction. On a large, busy dairy, restricted movement in the stall leads to bottlenecks in the feed alley, slower travel to the parlor, and just wasted time.
And on smaller dairies, I'd imagine it leads to significantly higher social stress and bullying because the optimal resting space becomes a contested commodity.
It does. The boss cows take the best spots and the others get pushed out.
And we need to address the tie stall listeners, too. While they don't have neck rails, the principle of lunge space still applies, right?
100%. For a tie stall cow, the length of her chain or halter must be sufficient to allow her to position herself without restriction. If she's forced to rest in poor posture, or if the bedding platform is too short, the same physiological penalty applies.
It's about fitting the stall to the cow, whether she's tied or free.
That's it. The takeaway for every producer is that the first step in maximizing your highly productive modern genetic animal is ensuring the environment is built for a 1,600-pound animal, not an animal from 15 years ago. If you haven't checked those rail or chain measurements recently, you are limiting performance before the feed wagon even begins its work.
Let's pivot now, because this is the part that I think is going to surprise a lot of people up north.
Let's pivot to a major myth that this research absolutely demolishes. The idea that heat stress is only a southern problem in the U.S. or purely an issue during the peak summer months of July and August.
Right.
We have to challenge that assumption because the data suggests you are losing money right now, possibly in late May, June, or September, without even realizing you've crossed the invisible threshold.
It's purely a perception issue based on human comfort. You know, when a human walks into a barn and it feels relatively cool or comfortable, say 72 degrees, we assume the cows are fine.
Where they go, it's a nice day.
Exactly. But Dr. Jeff Dahl's pioneering research out of the University of Florida is crystal clear and widely accepted. Dairy cows start to decline when the temperature humidity index, the THI, exceeds 68.
68, not 85, not 75, but 68. And for a quick reference for our listeners, that THI 68 threshold is roughly equivalent to 70 degrees Fahrenheit with 60% humidity.
Which is, I mean, that's a very common day in a lot of places.
It's an incredibly common weather pattern in the upper Midwest, the Northeast, and Ontario, especially during those shoulder seasons when the nights don't cool down enough or during periods of high humidity.
And the data supports this. UW Extension weather tracking services show that dairy cows in the upper Midwest and Ontario experience that THI 68 threshold for 50 to 90 days per year.
50 to 90 days.
That is 2 to 3 full months of compromised performance annually. And if you are in an older barn with poor natural ventilation or inadequate air turnover, those internal barn conditions are likely even worse than the exterior data suggests.
And here's the technical reason why. When the THI hits 68, the cow begins to struggle with evaporative cooling. She surrounds herself with a blanket of warm, humid air. We call this the boundary layer.
Right.
When the air around her is still or moving too slowly, she can't dissipate heat effectively. Even if the ambient temperature is 70 degrees, if the air isn't moving fast enough, the microenvironment at the cow's skin level can feel like 80 degrees.
That's where the magic of mechanical cooling comes in. The solution isn't just about dropping the temperature, it's about breaking through that boundary layer. The goal is to maintain 300 to 400 feet per minute of airflow right at the cow level, specifically designed to sweep away that humid, warm blanket.
It's physics solving a biological problem.
It is. But here's what they're not telling you. And this is the data point that should genuinely alarm every producer listening, regardless of where you farm. It's not just the current milk check that takes the hit.
This is what we call the intergenerational penalty, and this fact alone is a game changer for long-term dairy economics and herd health.
This is truly startling and requires its own dedicated moment of analysis. Heat stress during the dry period alters calf development in utero, a process known as fetal programming.
The heifer calf, the future of your herd, is permanently impacted before she's even born.
It's essentially baked into her DNA that she will be less efficient.
Dahl's longitudinal studies have shown that heifers born from heat-stressed dry cows produce 5 to 11 pounds less milk during their first lactation.
5 to 11 pounds less.
And crucially, that penalty doesn't suddenly go away in the second or third lactation. It lasts their entire productive life. We are talking about altered development of the mammary gland itself, often linked to changes in growth hormones like IGF-1 in the developing fetus.
So you are essentially setting a lifelong lower production ceiling on your future animals just because their mother was thermally uncomfortable for a few weeks while dry.
Exactly.
So if you are a northern producer thinking, oh, I'm only marginally uncomfortable for 10 or 15 days in July, you need to realize that those few weeks of dry cow discomfort can cost you tens of thousands of dollars year after year across multiple animals for their entire lifespan.
That makes cooling the dry cow pen an immediate, non-negotiable priority, not an optional luxury.
The return on investment for cooling dry cows is arguably the highest on the entire farm.
The simple fix, as you mentioned earlier, doesn't always require a major retrofit. It often means just adjusting existing infrastructure. We call the example of the Ontario farm. They didn't add massive new fans. They just redirected their existing fans over the feed alleys instead of blowing towards the back walls.
Right, where the cows spend less time.
And that small adjustment eliminated cow bunching, the behavior where cows clump together trying to find the coolest spot, which dramatically restricts access to feed and water and stabilize their intake. keeping butterfat performance steady all summer.
That's pure ROI through applied geometry and physics. The cow needs that airspeed to remove that boundary layer. If you get the flow right, the cooling happens passively, allowing her to regulate her temperature, maximize feed intake, and prioritize resting.
All right, let's talk dollars and cents now, because this is where the skeptical farmer needs to truly pay attention and challenge their existing spending habits.
This is the follow the money part.
It is. We are talking about the documented, verifiable return on that simple $50 investment. Cornell Pro-Dairy modeling, which is widely respected for its practical application, shows that adjustments like raising neck rails, a cheap fix involving basic lumber, mounting hardware, and labor deliver consistent 3-month paybacks.
With average returns of what?
360%. The initial investment is only about $50 per stall.
That 360% return is a staggering figure in agricultural economics. Let's break down what this actually costs per cow, per hundredweight, compared to what we typically spend.
Go ahead.
If you spend $50 today on improving a stall, and you gain even a conservative 2 pounds of milk per cow per day, at a milk price of $20 per hundredweight, that single stall pays for its adjustment in about 12 days.
12 days.
That is an almost unheard of speed of return in dairy farming. It's practically instantaneous profit.
Now compare that to a typical high-cost feed additive, a buffer or a bypass protein, which you pay for constantly every single day for the whole year.
You're just bleeding cash flow.
You are constantly drawing down cash flow, hoping for maybe a 5 to 10% return on the investment, and that return is often conditional on everything else being perfect. The infrastructure fix is a capital expenditure, a one-time cost that yields perpetual guaranteed returns as long as the barn stands and the cow uses the stall.
The economics are not even comparable. The $50 fix funds itself almost immediately, allowing you to reallocate operating expenses.
Sarah, I have to be the skeptic here.
Okay, I was waiting for this.
If it's truly this easy, if $50 buys me a 360% return, why are major equipment manufacturers still selling expensive, complex cooling solutions, high-end mattresses, or specialized sand delivery systems? What is the limitation of the simple $50 fix?
That's a fair challenge. The $50 fix addresses the geometry deficit, the neck, rail, height, and position, which is the most common structural bottleneck in existing barns. It solves the lunge space problem. However, the limitation comes when the problem isn't just geometry, but the overall system design. The $50 fix won't cool the air, and it won't fix poor bedding management.
So it's a first step.
It's the highest leverage first step, but it's not the complete solution for a truly broken barn. It unlocks the cow's ability to rest, but the quality of that rest still depends on the bedding and the thermal environment.
That makes sense. It addresses the friction point, but doesn't change the underlying material science. Yet, even with that nuance, the holistic economic benefits extend far beyond just the immediate milk line.
Right. Consider the documented results from that 450 cow herd in Western New York after implementing comfort upgrades. They dropped their cull rate by 10%.
10%. That's massive savings on replacement heifer costs, breeding costs, and the reduced loss of invested capital.
They also documented cutting their hoof trimming costs by a quarter. A reduction in lameness is a direct metric of improved stall comfort and reduced friction. Less standing, less walking on concrete, less abrasion on the hooves.
These non-milk metrics, reduced culling, lower vet bills, less lameness, are just as critical as the milk gain. And by the way, they still had a 5-pound increase in their herd average alongside those cost savings.
This connects reduced friction in the barn directly to significant labor savings and a calmer work environment. When you look at the farm owner's quote, it perfectly summarizes this philosophical shift.
What was the quote?
He said, "I used to buy almost every nutrition additive out there. Now my barn does most of the work."
That quote is the ultimate economic proof. The physical structure of the barn has transitioned from being merely a shelter to becoming the #1 labor-saving and cost mitigation tool on the farm.
It's working 24/7.
It's working 24/7 to reduce metabolic disorders, prevent injuries, and maximize the efficiency of the high-cost inputs you already have, like the feed and the genetics. It provides the stability the cow needs to utilize that expensive ration optimally.
We need to dive into some specifics now, because hearing that something is possible versus seeing the measurable gain from a real-world operation is a powerful difference maker for a skeptical producer.
Let's start with that Ripon, Wisconsin freestall fix-a-textbook example of high leverage, low cost. This producer made the quintessential minimal structural adjustment, raising neck rails by 4 inches and deepening the sand bedding.
And the result?
The documented result was gaining 6 pounds of milk, and the producer stated specifically, same cows, same feed.
6 pounds of milk without changing the TMR is a substantial gain, especially if they were already high-producing. And the research provides the clear mechanism. The cows gained 2.5 hours more rest per day.
Just from that one change.
That seemingly insignificant 4 inches of rail height was the difference between the cow being able to execute the crucial lunge forward comfortably when rising, or hitting her neck and deciding that the physical effort and risk of injury made it easier to stand in the alley.
That subtle behavioral change, multiplied across 365 days, yields 6 pounds of milk.
It's fascinating how quickly the cow adapts and rewards the producer when that friction is removed. They don't need convincing, they just need biological permission to rest properly.
And the bedding deepening is also crucial. It goes back to that comfort. It prevents hock lesions, improves stability, and allows them to position themselves, ideally, for long, deep bouts of rumination.
Then we have the Ontario ventilation solution, which is a perfect example of design efficiency over the brute force of spending.
Right, they didn't just buy more fans.
No, they didn't buy massive new fans. They simply audited their existing system and redirected their fans over the feed alleys where cows congregate for feeding, instead of blowing towards the back walls where they were creating dead spots of air.
And the immediate outcome was eliminating cow bunching and, critically, steadying their butterfat performance throughout the summer months.
That makes perfect sense. When cows bunch together, their feed intake drops dramatically, and that intake fluctuation is the enemy of steady components, especially butterfat.
By ensuring uniform airspeed and cooling across the entire area where cows spend the most time, they stabilize the cow's microenvironment, leading to consistent feed intake, consistent rumination, and thus consistent component yield.
Now, let's look at the largest gains reported in the sources. Cornell Pro-Dairy and Kansas State University case studies showed herds that underwent comprehensive comfort audits, improving stall space, bedding material, and airflow, simultaneously gained 2 hours of rest per cow daily.
And milk gain.
A shocking 8 to 9 pounds more milk per cow without changing the feed ration.
8 to 9 pounds is staggering. And I have to challenge this from the farmer's perspective. Is that gain genuinely achievable everywhere? Does that depend entirely on the severity of the initial comfort deficit? Because that number sounds less like a barn renovation and more like a major genetic breakthrough.
I share your healthy skepticism, Sarah, but I think the key lies precisely in your last point, the severity of the deficit. If the barn was truly broken, if the cows were only resting 8 or 9 hours a day due to terrible abrasive stalls and chronically high THI levels, then the 8 to 9 pound gain represents the unlocking of existing potential.
So the potential was there all along.
It means the premium ration and the high-end genetics were already capable of producing that milk. They were just physically and physiologically constrained from expressing their capability by the environment.
That is the critical mindset shift. Cows were not pushed to perform with a new supplement. Their basic biology was simply accommodated.
Exactly. Instead of trying to add a high-cost energy source to overcome the stress of standing too long, they eliminated the stress entirely. They let the existing ration and the existing genetics finally breathe and show their full capability.
In a modern, high-producing dairy scenario, that 8 to 9 pounds is essentially pure, high-margin profit, driven by a one-time investment in concrete, geometry, and air.
This also fundamentally changes the role of the nutritionist. You are no longer trying to formulate a ration that compensates for stress. You are formulating a ration that maximizes potential in a low-stress environment.
This entire body of research points to a significant philosophical shift happening in top-tier herds globally. They are moving away from what we call managing stress, which is inherently reactive, always putting out fires, to designing systems so that physiological stress never builds in the first place.
And this proactive approach is exponentially more profitable than a reactive one. When you are constantly managing stress, you are allocating high-cost labor and veterinary expertise to fighting lameness, addressing metabolic issues post-calving, and dealing with massive fertility dips in summer.
All that firefighting.
When you design the system correctly, when the cow is comfortable 13 hours a day year-round, those high-cost problems simply don't surface with the same frequency.
The Minnesota dairy manager, quote, captures this operational shift perfectly. We quit trying to manage around cow comfort. Now the management kind of takes care of itself.
That is a profound statement. It suggests that good infrastructure drastically reduces the required daily labor, expertise, and mental fatigue for daily problem solving.
It means your managers can focus on genetics and strategy, not fixing hawk lesions.
It creates stability and predictability. And that stability is the true value proposition of infrastructure versus human labor. Dr. Mike Hutchins' quote is often cited for a reason: infrastructure never takes a day off.
And that stability is precisely what complements the high-level management efforts. A properly fitted stall works 24/7/365. A well-placed fan set on a thermostat works 24/7. They don't get tired, they don't call in sick, and they don't require constant supervision.
They're providing constant, stable, optimal conditions. That consistency is something no human manager, no matter how dedicated, can replicate alone. They guarantee a baseline level of comfort, allowing management to focus on maximizing the margin above that baseline.
We must also emphasize that the source material specifically ensures the listener knows this isn't just a large freestyle discussion. The principles apply universally.
Right, this isn't just for the 1,000-cow dairies. Tie stall and dry lot systems achieve similar economic returns when cow biology drives design, rather than just human habit or tradition.
Absolutely. For our listeners running tie stall operations, the focus needs to be on allowing that cow's biology to dictate the design. That means prioritizing deep, clean, dry bedding, optimizing chain length and stanchion alignment to allow for proper head movement when rising, and ensuring adequate clean water space.
If a cow in a tie stall isn't comfortable, if she is struggling to shift her weight or rest symmetrically, she won't rest those critical 12 to 14 hours, and you lose milk just the same.
Similarly, in dry lot systems, comfort often boils down to shade and footing. The simple provision of properly sized shade structures and consistent, dry, well-maintained footing ensures cows can exhibit natural resting behavior and avoid the chronic lameness that comes from standing on uneven, wet surfaces.
The principle remains: remove physical friction to maximize biological efficiency.
Now we get to the core of the dilemma, the operational and psychological bottleneck. If the data is this compelling, if a $50 investment yields a guaranteed 360% ROI, why do structural improvements still lag across the industry?
Right, why isn't everyone doing this?
Why is the focus still overwhelmingly placed on the often marginal returns of a new feed additive?
This is the psychological bottleneck identified by farm economists like Dr. Cameron King of the University of Guelph. He calls it the visibility problem, and it perfectly explains the producer's budgetary behavior.
A visibility problem.
Producers, being rational but busy economic actors, invest their limited time and money where they see the fastest, most immediate feedback.
Okay, that makes sense.
The visibility problem means this. I spent $1,000 on a new high-bypass protein source in the ration. I see a small but immediate quarter-pound gain in the tank tomorrow, and I feel instantaneously good about my decision. It validates the purchase.
Instant gratification.
Exactly. Conversely, I spend that same $1,000 fixing a series of neck rails and deepening bedding. I might see the gain materialize only over 3 to 6 months, initially showing up as lower vet bills, fewer hawk lesions, and calmer behavior quiet gains that are hard to measure day to day.
Infrastructure improvements return slower, yes, but the total payoff is much bigger, vastly more long-lasting, and more comprehensive in its benefits, affecting reproduction, health, and yield simultaneously.
The peace, comfort, and stability, the quiet gains of removing friction, are hard to quantify in a daily milk check report, making them dangerously easy to defer in the annual budget meeting.
And this creates a vicious cycle. The deferred maintenance creates stress. The producer compensates by spending more on expensive feed to push production. The high feed costs make capital investment in the barn seem unaffordable, and the cow continues to operate below her genetic potential due to the comfort deficit.
So this is the tough, practical question we need to pose to our listeners as they drive to the feed store. Everyone's saying chase the latest nutrition trend or the newest feed additive. But what if the money spent on that ongoing operating expense should have been strategically invested one time into the air compressor, the lumber, and the skilled labor required for those simple structural corrections?
The cost of fixing the barn is known, measurable, and fixed at $50 per stall. The cost of ignoring the barn is hidden. It shows up in chronic lameness rates, reduced fertility, high replacement costs, high cull rates, and most damagingly, in the lower overall efficiency of every high-price input dollar you already spend.
The hidden cost is always far higher than the known repair cost. The operations that truly thrive are the ones who notice the reduced friction first. The herds are calmer, there are fewer metabolic issues, and the transition periods are smoother.
The milk data often comes second.
Exactly. The milk data confirming the success often comes second to these critical behavioral and health observations. They realized that they weren't buying milk, they were buying efficiency and stability.
Which brings us back, full circle, to the final mantra that should govern every decision on the farm budget: foundation before feed. The structure of the barn sets the biological ceiling.
The infrastructure determines the maximum efficiency of every input dollar you spend, whether that's genetics or feed.
Get that order right, comfort first, and everything else, ration utilization, reproduction success, and ultimately, profitability starts falling into place naturally.
Okay, let's get actionable.
All right, Jake, let's bring this down to brass tacks. Our farmer listener just finished morning milking. They're driving to the feed store, maybe thinking about that new bag of additive they heard about. What are the 3 most actionable things they need to know from this discussion, broken down into immediate, medium, and long-term actions?
We want action, not just theory. They need a prioritized checklist based on that high ROI data.
Okay, immediate action this week, the diagnostic checkup. This is about rapid diagnosis using simple tools.
You need to implement 2 quick, highly reliable ways to gauge comfort immediately. First, the 25-second knee test for bedding quality. This is personal and objective. Kneel in the most used part of a stall for half a minute. If it's painful or if your clothes are damp or wet when you stand up, it is failing your cows.
It's that simple. If it's not comfortable for your knee, it's not comfortable for her.
Exactly. Cows need dry, deep, non-abrasive bedding to prevent injury and encourage rest.
And second, perform a behavioral check. Look the cows midday, about an hour after they've finished eating and have returned to the stalls. You should check that a minimum of 80 to 85% of cows are lying down comfortably.
Not just lying down, but resting and ruminating. If you see cows standing, or worse, half resting with their back legs slightly tucked and their heads up, your stalls are the friction point.
If you are failing either of those quick tests, adjust bedding immediately. And pull out that tape measure to check that neck rail height against the research-backed 48 to 52-inch guideline and the 68 to 70-inch curb distance. This is the fastest, cheapest ROI you will find anywhere in your operation.
All right, number 2, medium-term strategy, next 3 to 6 months. Airflow audit.
This requires a cheap investment in a simple, handheld device to monitor THI and airspeed, something that can be purchased for less than the cost of a single ton of specialty feed.
And you need to monitor THI at the cow level, not just the ambient temperature outside the barn door. You must target immediate active cooling actions whenever that THI exceeds 68 degrees Fahrenheit, regardless of the month on the calendar. That means fans on, soakers running, and maintaining a schedule.
And crucially, verify airflow speed. Don't just assume the fans are working. If your cows are warm, don't just add more fans. Verify your existing fans are hitting that critical speed of 300 to 400 feet per minute of airflow right at the cow's back, where it matters.
Budget for adjusting existing fan direction or installation height, especially targeting optimal flow in the dry cow area. Remember that intergenerational penalty cooling the dry cow is an investment in your next 5 lactations.
And finally, long-term positioning next 1 to 2 years. Recalibrate the system.
Focus on designing systems to prevent stress, not just managing it. Utilize that reliable 360% ROI opportunity from your quick stall fixes and ventilation adjustments to fund the next phases of permanent infrastructure improvement.
Whether that's a dedicated sand bedding delivery system, specialized mattresses, or permanent high-pressure cooling infrastructure, this builds physical equity and systemic stability into the operation.
And this is the most exciting part for your bottom line and your nutritionist. Once comfort measurably improves, cows eat differently and utilize energy more efficiently. Their maintenance energy requirements drop, their rumination increases, and their transition period is smoother.
You must work with your nutritionist to recalibrate the ration to reflect the cow's increased energy balance and production potential. You might find you no longer need that high-cost additive because the cow is now utilizing the base ration more efficiently, saving you money on inputs while increasing output.
This has been another intense deep dive from the Bullvine. If this kind of impartial, data-driven analysis helps your operation focus on where the money truly is, in the concrete, air, and shade, head to www.thebullvine.com for more articles that tell you what's really happening in dairy. We focused on getting the foundation right, ensuring that infrastructure is paying its way, and acting as your partner in profitability.
And seriously, subscribe wherever you get your deep dives. We're releasing new insights twice weekly now, and trust me, you don't want to miss what we've got coming next week. We're going to be dissecting the new economic modeling concerning milk components and the future of pricing structure.
Ooh, that's a big one.
It is. We'll discuss how the market shifts reward efficient component production over sheer volume, and how that changes everything from breeding goals to feeding strategies, potentially making high component herds the big winners of the next decade.
Tune in next time for that analysis.
Remember this final provocative thought. Infrastructure is the one system on the farm that works 24/7 without supervision. Are you letting your infrastructure reliably pay you, or is it quietly costing you? Go measure those neck rails today.